Hello students, I am Sanap K.B. from Department of Physics, RBNB College, Shirampur. This is my last lecture on the topic magnetic fields due to electric current for 12th science subject physics. Now today we are going to new article, that is Ampere's law or Ampere's Circuital Law. Today we have to see about this Ampere's law. First see the statement of this Ampere's law. Statement: the closed line integration of line integration of magnetic field of current conducting loop, is equals to permeability, that is the absolute permeability, 1 minute, equals to absolute permeability times current flowing through conducting loop. This is the statement of Ampere Circuital Law. I repeat again, the closed line integration of magnetic field of current conducting loop is equals to absolute permeability times current flowing through conducting loop. That is mathematically we write that closed line integration of B dot dl is equals to mu 0 times I. This is equation 1. This is the mathematical statement of Ampere's law, that closed line integration of B bar dot dl bar is equal to mu 0 times I. Now we have to explain this Ampere's Circuital Law. Now see the explanation. Now here our simplicity, we consider this current carrying closed loop. Now here is the magnetic field V and this element is dl. Now this Amperian loop, this is known as Amperian loop here. Now this is the current I1, this is current I2. Now here this is current I3. Now this is current I4. Now here this symbol dot in a circle indicate that electric current directed in outward, and this symbol that cross in a circle indicate that current directed in inward direction. Now here current enters through this one and current leaves from this loop one. Now here in this Amperian loop, this I1, I2 and I3 are current in it, and this current I4 is outside the Amperian loop. Now according to this Biot-Savart law, this magnetic field B and this length element dl both are here tangential to that Amperian loop, and now direction of that current will be shown by right hand rule here. And now this we apply this here Ampere's law like this one, this closed line integral of this B dot dl is equals to mu 0 times that is a current enclosure in that Amperian loop, and therefore I1 this plus I2, then this is a I3. Now here current which is directed in outward direction that treated as a positive, and current enters in inward direction that is treated as a negative, and therefore this equations becomes mu 0 in bracket I1 plus I2 minus I3, and now this current I4 outside the Amperian loop is not considered here. Only we consider that current enclosure in that Amperian loop, and therefore this closed line integral B dot dl is equal to this current mu 0, that absolute permeability mu 0 times that current which is interior current. And now this is the another statement of this Ampere Circuital Law, that is a closed line integral of B dot dl is equal to mu 0 times that is the current in that interior of Ampere's loop. Now in this way we state the Ampere's law and we explain here. And now if this magnetic field V and this length element dl are tangential, that are parallel, and therefore angle between them theta will be 0, and we can write this line integral B dl is equal to mu 0 I interior. Now solving this dot product, value of this B bar dot dl is equal to B dl cos theta. Now here value of theta is 0, and then cos 0 is a 1, and then that equation becomes that line integration of that B dl is equals to mu 0 times that current. Now replacing this dot product by this only B dl if this B and dl are parallel to one another. In this way easily we can explain this Ampere Circuital Law or Ampere's law. Now we have to see the next article that concerned with this Ampere's law, that we have to find magnetic field, applications of this Ampere's law, magnetic field of a solenoid. Magnetic field of a solenoid. Now this is the first application. Now here applications of this Ampere's Circuital Law. What is meant by solenoid? Solenoid consists of some non-conducting solid rod. On that rod, that conducting wire is wounded on it. Now here current I will be flowing through it. Now here this conducting wire which is wounded on a non-conducting material, and this wire is again wounded on this non-conducting rod which is known as a solenoid. Actually, what is the solenoid? Now removing this rod, then structure of wire becomes like this one. And now here current I living through this solenoid. This structure of this conducting wire is made, which is known as a solenoid. And now we have to find what is the magnetic field produced by this solenoid. For that purpose, we have to use here Ampere's law. And then take the vertical section of this solenoid. Here direction of current will be like this one. This is direction of current. Then and now current will be here. Means here currents enters through that solenoid, and then from this one current which is directed in outward. In this way, inward, outward, current will be flowing through that solenoid. For our simplicity, we have to find what is the magnetic field of a solenoid. We take the horizontal section of this solenoid, and structure of that solenoid will be, we draw here. See, what is the horizontal section? Now here horizontal section. Now now this symbol indicates that current directed inward here, and now here this current which is directed outward. And now we have to find a magnetic field B here. Now here magnetic field B is maximum at the center of this solenoid, and strength of magnetic field outside the solenoid is a very low, which is neglected, which is to be 0. That is a large strength of magnetic field is present at the center of solenoid here. Now our simplicity, we draw the here rectangular loop. This is a loop A, B, C and D, and now here is the magnetic field which is directed like this one. And now we have to find what is the magnetic field produced by this solenoid using this Ampere's Circuital Law. Now this part is the Amperian loop. Now we write here Amperian loop A, B, C, D, means this direction of current is like this one. And now we have to find the value of B using this Ampere Circuital Law. Now here from that Ampere's law, that line integral, that is a closed line integral B dl, okay, from A to B, okay, plus closed line integration of from B to C of that B dl, plus line integral from C to D here of that B dot dl, plus line integral, closed line integration of that from D to A, means this rectangular frame is completed here of that B dot dl is equals to that mu 0 times that current I. Okay, now here we explain detail about that Amperian loop of a solenoid. See that figure is there. Now this small I B current per unit length. Now this capital LB length of that Amperian loop, and small nb number of turns of current carrying wire, and therefore here net current, that is I net, becomes that Ni. This is I be the current per unit length. If there are n number of turns, the net current will be Ni for this length L. Now here length L, this is the length of this rectangle. Now we have to find value of this equation. Now closed line integration from A to B. Now A to B is as it is. Now here we continue that closed line integral B dot dl from A to B plus. Now here value of that closed line integral from B to C. Now here B to C. Now here magnetic field and this length element both are perpendicular to each other, and then this value of that closed line integral of that BDL from B to C, okay, is equal to BDL cos theta from B to C here. Now here B and dl, that is the length, total length. Both are perpendicular, that is theta is equal to 90 and cos 90 is equal to 0, and therefore this term is completely 0. B dot dl from B to C is equal to 0 here. Again now consider this second term, that is a line integration from C to D, means this term. We know that magnetic field outside the Amperian loop is a 0, and therefore line integration from C to D of this B dot dl is equal to also 0. Again consider this fourth line integration, that is a line integration from that D to C, means this one, D to A here, D to A of this B dot dl. Now here B and this length elements are perpendicular to with another, like this one. This value is also 0. Theta is equal to 90 degree and cos 90 get the 0, and therefore value of this integration and this integration get 0. And now this equation becomes, that is a line integration only remaining, that is from A to B of this B dl plus 0 plus 0 plus 0 is equals to that mu 0 times that current interior, that is the net current. Later we consider that one. And now we write this equation as, that is a B line integration from A to B dl. Okay, this plus 0 all this term is 0 is equals to mu 0. Put the value of this I net, that will be N I L. Okay, now here that conducting wire, that is a AB, or all that rectangular wire is made up of large number of small elements dl, and therefore this line integration of this dl is the total length of that solenoid, and that value will be L with the length of that loop, and therefore this equation becomes that BL is equals to mu 0 NIL here. Okay, this L get cancelled, and then value of B, that is a magnetic field of a solenoid, is equal to mu 0 Ni, mu 0 Ni, where I be the current per unit length. Mu 0 is the absolute permeability, and N be the total number of turns of that conducting wire wounded on that solenoid, and now B is the magnetic field produced by that solenoid, which is given by B is equal to mu 0 Ni. In this way, easily we apply this Ampere's law, and we can find the magnetic field of a solenoid. And now only small article is remaining. Now we have to discuss that the magnetic field of a toroid. What it mean by toroid? We have to see here. Second application, that is the magnetic field of toroid. Magnetic field of toroid. Now What it mean by toroid? Now this solenoid is bent in a circular path, that is a endless circle. Only difference is that solenoid is here a straight line, and now this solenoid is bent in a circular path, that is a endless circle. Now this is the structure of a solenoid. Now here that horizontal section of that solenoid is bent into circular path, and now here section of that toroid will be like this one. Now this is that circulating coil wounded on this one, and now here is the current I will be entering and current I will be leaving. Here is the center. Now you know that the magnetic field is present at the center of solenoid. So here this is the center of again solenoid, that is circumference of this circle of radius r. R with the radius of that toroid. And now we have to find magnetic field B at the center. Now here we saw again that these currents which are outcoming, and this inner part shows that this current is in directed inward direction, and this current is in a outward direction. Then what is the magnetic field produced by this toroid? Applying that Amperes Circuital Law. Now this is the Amperian loop, and now line integral, that is B bar dot dl for this toroid is equals to mu 0 times that current, where IB current flowing through a toroid, and capital NB number of turns of that conducting wire. Then therefore net current is equal to Ni, and now this Ampere's Circuital Law becomes closed line integration of this B dot dl is equals to this mu 0 times Ni. Okay. Now here R be the radius of that toroid, and what is the circumference? 2 pi r is the circumference of this toroid. And now modify that equation, that is B closed line integration of dl, okay, is equals to mu 0 times that Ni is the net current. But this value of that closed line integration, that is a dl, is equal to 2 pi r, that is the circumference of that circle. Circumference 2 pi r. This circular path, that is the total length. Now dl be the small element of the length, and now substitute the value of that closed line integration of dl is equal to 2 pi r in this equation, and therefore that above equation becomes that this equation, that is b into this dl is the 2 pi r is equals to mu 0 times ni. Okay, and now from that one, what is the value of b? Will be mu 0 ni divided by 2 pi r. This is the magnetic field produced by this toroid, and in first application we obtain that magnetic field of a solenoid, and here we get the magnetic field of a toroid. What is meant by toroid? Toroid is that straight solenoid is bent into form a circle, that is a endless circle, only that one, and we find the magnetic field B at the center of this path circumference, and that value comes to be B is equal to mu 0 ni upon 2 pi r. Now here this term, that is a mu 0, that ni net current, and 2 pi, these terms are constant here. Mu 0 ni 2 pi, all these terms are constant, and then we get B is inversely proportional to R. What does this equation indicate? That magnetic field produced by toroid is inversely proportional to radius of a toroid. Means as radius increases, magnetic field decreases. As radius decreases, magnetic field increases. And in this way, we saw about what is the statement of Ampere's Circuital Law in words and mathematically. We explain that the Ampere Circuital Law, now this current is the interior current, that is inside that Amperian loop, and using that Ampere's mathematical law, we find the magnetic field of a solenoid here, and again a magnetic field of a toroid here. In this way, we finishes the topic, this magnetic fields due to electric current. Okay.